Okay guys, hello and welcome to the BRES 2021 launch. We're sorry that we're having to do it this way. We would all much rather that we were actually meeting or presenting to you guys in person. It's a little odd, but hopefully we can all work around this and adjust. I know that you guys are having to anyway in your lectures. So without further ado, let's get started. So basically, what is BRES? Is probably the best question to start with. So we are fundamentally a community of like-minded people who like to design, build, and test things. And we do this through a variety of projects and activities and workshops and such. I will say that we're open to absolutely everyone. So whatever department or experience level you are, you're welcome on board. And we want to help those that have little experience, and we would love to work with those that know exactly or more comfortable with what they're doing. So what are you going to get out of joining? What are you going to get out of this year? Well, firstly, you're going to learn hopefully quite a bit. We've got some training resources for you guys. We've got access to equipment and tools that we're trying to provide to you guys, especially in this virtual term, that I'll touch on more later. Developing. So as well as, applying your theory, because you'll be doing a lot of theory at university, especially this year, applying that practically or to a project specifically can be, fun. It's more real world. So you'll develop your skills in that way, because practical things are never the same as theory. You'll come to find out, unless you know already. But you'll also hopefully learn new skills from, each other in this kind of community, or, perhaps from the project leads themselves. We also provide a fair amount of CV material. I mean, unless you've worked on these things before, which some of you might have, this will really help you stand out in the field, and you could possibly gain some awards as well. Really punching for some competitions this year. On top of all of that, the main point is to have fun and have a great time. So I know that I have, and I'm sure a lot of other guys on the team could also stand up for that as well. So what do we do in a bigger sense? So breaking it down, firstly, I will just make a disclaimer. We are not experts, lecturers, magicians, trainees. We're not qualified for all of this. This is very much a volunteered thing. We will provide you the resources to kind of get what you want done and push you in the right directions. But you will have to apply yourself. You will have to do some extra reading and such. It sounds a little bit dull, but it's just our way of saying that you can't fully rely on us, okay? The projects. So the projects are at the forefront of what we do. Essentially, we put you guys into various teams of really, really fun kind of subjects, and then you guys can work together on them, have all the resources. We've got some funding for it, and lots of other stuff. But the projects are the key kind of element. We also include some talks. Sorry, just missed out. These are the projects that you will be working on in the year. So you've got drones, rockets, electric vehicles, medical robots, and fundamentals. We'll be touching on all of these as we go. Talks. Now, talks are a great opportunity to meet with industry speakers. So talks basically provide an opportunity for you guys to network with the speakers. If you're interested in that industry, it's a great opportunity to learn new things because they will be talking about upcoming technology and what's relevant, what's new. It's also a great opportunity to experience firsthand or hear what it's like working in that industry. If that's a field that you're interested in getting involved in, then it's a great chance to kind of experience and hear from them and ask questions about what it's like to be there. Lab access. So this is a big one that we're working on because of COVID, but you will be able to work on the main BRES projects as well as some of your own stuff, as long as it's appropriately risk assessed. As well as that, we also offer socials. So we do launches, we do flight days, we have parties, and general little mess abouts and kind of fun activities throughout the year. So I should probably have introduced myself, but I'm going to do it now. My name is Ben Munya. I'm the chairman of this society, and I also founded it a few years back. We also have Ed, Ali, and Sam. Now, Sam and Ali are both on placement this year, but because it's a virtual term, you might see as much of them as you see of everyone else. Ed is finishing up his PhD, so won't be here to present himself, but will be leading some of the project work as well. And then all of the team leads, Josh, Guy, Tom, Ryan, and Manal, are all going to present themselves throughout this presentation. But essentially, here you can see who to go to and who you'll be kind of interacting with throughout the year. So the agenda, what are we going to go through in this launch? So we've done the introductions, we've got that out of the way, but now we're going to talk about how we're going to cope with the virtual term. Then we'll introduce some of our sponsors. We'll touch on some basic training that we're going to offer you guys. We've got some project presentations from the leaders. Then we touch on some upcoming events, so what you can expect in the following weeks. Summarize all of that up because I know it's quite a bit to handle, and then there'll be Q&As at the end. Okay, so in terms of a virtual term, I will admit Term 1 is set to be primarily virtual. We have to follow government guidelines, obviously, so there will be a lot of kind of design and simulation stage. So it's a good opportunity to do training, which is what we'll do a lot in the first term. Lab access, this is kind of unclear. It's a grey area at the moment, but we're working with technical staff to give you guys as much access as possible. Currently, we're only allowed a maximum of 4 people in at a time, and if you are not committee, you have to be supervised by a committee member because there's a lot going on in there. And then we also have 1 person, if you just want to put on a 3D print, we're working on that as well. So almost 5 people in the lab at the moment, but we have a nice lab set up with all kinds of tools, equipments, as I've said, 3D printers, soldering irons, and lots of materials for you to play around with. 3D printers, as we've said before, will be primarily for project work. We will be implementing a supervised booking system. So, through the coming weeks, as we know, we will let you guys know how you guys can get access to that and how we can make everything a little bit more fluid. Team organisation, so how we're going to be running. In previous years, we've just primarily used WhatsApp, and then we've obviously met up in person. This year, we're going to implement Teams because you'll have a Teams account, so it makes sense. And so we will have basic crossovers. So every Teams chat will also have a WhatsApp chat so that you can be more on the go because we assume people are more, liking to WhatsApp. There will be a general society chat or a broadcast, essentially where we'll update you with all the events and things that are coming up. Then there'll be a group for each one of the projects, so drones, rockets, and such. And then some perhaps for some extra events that we'll be doing if it needs an extra focus group, then we'll add that. This will become more understandable as we go along. I know it's quite a lot to understand, but essentially main focus is Teams. You can all join, have virtual catch-ups, and find out what the projects are doing. So sponsors. Okay, so quite excitingly, we've got 3 sponsors secured already for this year. The first one is Roboton.io. So Roboton.io is basically a virtual platform, where you can compete and run simulations. So you can design, program, and simulate various things for different challenges. And it's all within a browser, so you don't have to download any extra apps. But they are providing us with free access, for you guys, to the virtual sumo package until Christmas. And you'll find out more about why in a little bit. But first, let's take a little look at this video. So here, this is the line follower package. And on the right, you can see they are basically doing some programming that you can do in various languages, adjusting some parameters, and then they can run the practice or simulation. And here you can test out basically how your code would work on the actual model. So that's quite exciting, and there's a lot you can look into there. We'll be working and mentioning more about them throughout the year. Secondly, we have Student Circuit. So these guys are offering an online free learning platform that covers all of the basics in electronics all the way up to final year and higher end stuff. As well as the resources, there's various online quizzes and tests and things you can do to kind of increase your knowledge. And also they offer a lot of advice and sharing projects. It's a great community, so you can find out or talk to them about what might be best for any projects you're undertaking. As well, you can turn to us as well. Here's a little video from them. Okay, and lastly, quite excited to announce that we are partnering up with JCR Acoustics. They produce high quality DIY speakers, and they're a lot of fun to assemble and basically understand the basic principles of what goes in a speaker and the assembly involved. The founder of that company, JCR, is actually a BRES alumni, so he was working with us 2 years ago, and so it's quite exciting to see how far he's come and what he's up to now. And he's going to be offering BRES members discounts on certain items to get you guys started. So that's to look forward to. That was just a short clip from JCR. Okay, so next up is bootcamp. One thing that we're going to primarily focus on this year is getting across the board understanding in the basics. So this basic training will be going on for 3 weeks. So this will be the initial 3 weeks starting next week. 3 weeks of basic training for all BRES members. It's not compulsory. We're not going to force this on anyone, but we do advise those that aren't confident in these kind of skills. It's a great opportunity to get some free understanding and live Q&As. Those that do feel like they're above and beyond this, it doesn't hurt to brush up on your skills. And if you can then offer help to those that need it. But also, we might be touching on some things that you haven't come across yet. So we kind of urge everyone to look at this so that you've got the basic skill sets for the upcoming projects, because that could be quite a jump for some people. So this will be every Tuesday and Thursday for the next 3 weeks at 5:30 o'clock. 5:30 o'clock. Starting next Tuesday, okay, on the 20th. So what we'll be doing during bootcamp, we've got 3D design and printing, circuit theory and practical studies, and intro to programming. Okay, so just to break those down a bit. 3D design, we'll be introducing Fusion 360. This is obviously the kind of software that the university has gone with, and we'll be going over some basic commands and stuff that you need to know. Mostly the kind of common mistakes that you do when you kind of first start out on this. So it'll be kind of touching up and helping you all out, understanding how to use it. And then how to design for 3D printing. Very often we see people, and we've experienced it ourselves, understand how to design something, then manufacture it on a 3D printer like that, and it turns out completely differently, or things don't fit, or you've not thought about the orientation. So we'll be touching on the kind of basic things you need to think about in order to get a good 3D print at the end. Okay. Circuit theory. So I will be taking you through basic theory and testing. Wish me luck. So we'll be going over some basic electronic components, some circuitry, and how to simulate that as well. So basically testing whether things are going to blow up or not. And then we do some practical skills. So unfortunately, I'll have to do that over video, but we'll do some common skills and things that you need to know to make sure that you don't A, hurt yourself, and B, make a kind of good product at the end. And then finally, in the programming session that Ryan will be running, so I'll introduce him later, we'll be learning kind of programming interface. So how to kind of work with Arduino mostly, and then understanding the programming language, so the syntax involved, and then using that with circuitry. And then finally, we'll run a 6th session on programming design. So how you take an idea or like a structure that you want and implement that into code and get that to run the right way, and then kind of general debugging tips and such. So these bootcamp sessions, again, I will urge everyone to try and get involved with and see how well you do, because it's a really good opportunity for some free learning. Okay, so now we're going to slide over to the project presentations from some of our leaders. You're going to hear 5 talks about their year plans, what the projects are. Please note that after the launch, you will have an opportunity to chat with the project leaders during our Q&A sessions, and you will be able to sign up to them afterwards. Okay, so just enjoy the 5 presentations, and then you can ask questions at the end. Okay, thank you.
Thanks, Ben. Hi, everyone. My name is Guy Harding. As mentioned, I am heading up the drone section of BRES for this coming academic year, and I'm briefly just going to take you through what we do, what we have done in the past years, and what we are planning to do in the forthcoming year. So without delay, let me get into the PowerPoint. What we do here is for everyone to have fun whilst learning new skills that they can use further in their course, in the workplace, or as something just to relax and enjoy. I know that sounds a bit like a cliche, but it's something that I experienced in BRES during my first year here at Brunel, and I still believe it to hold true. Okay, so let's get into the real drone side of things specifically. So last year, our focus was on working towards having fully autonomous drone capabilities, which could be implemented into the UAS challenge or any other aircraft-based UAS challenge. Our testing was cut a little bit short at the end of last year, however we did manage to successfully achieve semi-autonomous capabilities. This is demonstrated in the video on the left. In this test we carried out, if the drone, if left its boundary we had demarcated, it would return itself home and land. Besides this main project, we also carried out fun fly days where we would take our other BRES aircraft out to fly when the weather allowed it. We currently have our own first-person view racing drones with a full racing course, which is a great way to test your skills in a semi-competitive environment. Lastly, let me move on to the main drones project for the year 2020 to 2021. We are very excited to announce that we will be working in conjunction with National Formosa University in Taiwan for the design and testing phases of a carbon fiber flying wing. This aircraft will be designed for the purpose of conducting aerial surveys using traditional or infrared camera equipment. If you are interested in the design of aircraft, autonomous systems, electrical system integration, or just interested in having fun flying, I would thoroughly encourage you to join us. If you have any questions or queries, don't hesitate to contact me. My email address is here on the slide, or you can get hold of me through any of the BRES social media accounts. Thank you very much.
Hello, so as Ben said, my name's Josh and I'm going to be leading the BRES Rockets project for this year. So, a little bit about me. I am a second year aerospace student on the Integrated Masters programme. I joined Brunel and BRES last year in 2019, and last year I was mainly part of the team who helped design the grid fins and the mechanical side of the project, and I will be leading the project for this year. So, a little bit of what we actually do in rockets. We learn about rocket science concepts, so things like centre of pressure, how the fin size affects the stability, rocket motor classifications, rocket launches, and health and safety. We do all the CAD modelling and designing of different components, which you can see in this picture here, which I'll quickly move myself. So that's the grid fin canister we made last year. We also make the flight computer system, so that's stuff which deals with the height of a rocket, speed reached, and more specifically last year, self-correcting flight mechanism. We do a lot of 3D printing, so shown in this picture. We also have launch days, which hopefully we'll be able to run this year, and we like to hang out and talk and just generally have fun. So a bit of what we did last year. So we designed the grid fins. Well, me personally, we designed the grid fins. We also designed different nose cones. So the one shown in this picture here is for the camera unit, which we would have had in the front of a rocket. We created an active guidance system, which is shown in this GIF here, which I'll quickly move myself out of the way again, which is was a system which essentially tried to recorrect the rocket to try and return as close to where it was launched as possible, which sort of sounds like a guided missile, but as it wasn't propelled on the way back down, it wasn't, for legal reasons. Then we also 3D printed our own coupling mechanism and created the flight logging equipment. So these are a couple of pictures from one of our launch days last year. So this was the initial prep of the rockets that we built. So that was the stuff like putting the motors in, putting the cladding in, putting the parachutes in. This was the actual setup, so we launched 2 rockets at a time. And this is a picture of one of my mates, James, actually launching a rocket. And we'll have some GIFs. So this was me launching a rocket from last year. Which... Oops, sorry. There we go. It just shows it was in a field. Of course, you have to launch it away from public spaces for health and safety reasons. And as you can see, you very quickly lose it in the sky and you can't properly follow it, which was always an issue with having like black rockets with only a small amount of red and finding them. And this is Ed, who was the leader of last year's rocket team, launching a rocket that they called the pencil because it was designed to look like a pencil. And this one was infamous of launching and getting stuck in trees, which happened 2 times we launched it last year. But yeah. So, this year we're going to be entering into the UK SEDS rocket competition, which tasks us with creating, designing and launching a rocket with a fixed motor size to the greatest possible apogee, so the greatest height reached. The conditions that we have to meet is we have to custom make everything, so we can't use any pre-made parts, so we'll have to design the actual casing, the fins, the nose cone, the computer flight systems, and we will also have to produce accompanying design documentation, so we'll have to show how it's designed. We'll have to also run some flight sims in rocket software to show how it should theoretically perform, and then actually have an assessed flight, which is what we'll submit at the end. So the structure in term 1 will mainly be we'll start off with a taster project on trying to make our own rockets at home, and hopefully we'll get most of the CAD and rocket sim training done and beginning to create the CAD models and the design documentation, so that in term 2 we can finalise all the design documents, 3D print and manufacture most rocket parts, hopefully have a couple of test launches before the actual final launch day. So why join rockets? You get to actually build and launch rockets, which, come on, it's really cool. It looks good on your CV. We're the only team of BRES where you're allowed to use explosives, which is also a plus. You get to learn in a fun, relaxed environment, because, once again, I am a second year student, I'm still learning, so it will be a really fun experience. You get to say you're technically a rocket scientist. We have fun socials when possible. It's open to anyone of any skill level, so it doesn't matter what course you're in, we just want people who are excited and engaging with the project. And just good experience working in a team, which also enjoy doing the project as much as you do. And hopefully running launch days in term 2. So, thank you for listening. I'll be around in the Q&A sessions afterwards, so come and ask any questions you want to about the project, about BRES, or just uni in general. So, look forward to meeting some of you.
Hello everyone, I'm here to talk about the BRES electric car project. A little introduction of myself. My name is Tom McCann. I'm an MEng level 4 student studying EEE. We are running 2 cars this year. We've got an electric go-car and a Formula Student race car, which is kind of an introduction to Formula 1 through a Formula Student program. So if you're a Formula 1 fan, this is definitely a car you want to be building and getting to know. A little bit of an overview of the Formula Student race car. Every year we go to Silverstone and we take it around the racetrack, where we compete in a variety of events, ranging from an acceleration test to a handling test, things like that. You get scored points, and whoever scores the most points wins. So to score the most points, we need a fast car. And to get a fast car, we need high voltage. We need to conform to a lot of industry standards because we're working with a very dangerous vehicle. So a lot of safety systems need building, and a lot of efficiency systems need building. How can we get as much power from the batteries to the motor, etc.? So what specifically are we building? Well, we need a startup sequence to meet the rules and requirements that you need to race. Specific startups are required, multi-action startups, things like that. We need a charging and discharging system. This is to charge up and discharge the linking capacitors within the car so that we don't blow any of the electric components. Very important. We've got a pedal system that needs building. Well, that's just obvious. We need to have controls so the person driving it can race it. Battery management. This is so that the car doesn't blow into flames when we discharge and charge the batteries. We need a motor controller tuning. This is all about efficiency. How can we get all the power from the batteries into the motor and not lose it along the way? And we need insulation monitoring. That's to stop you touching the highly conductive metal car and killing yourself through the high voltage. That's all making sure that the chassis is nice and grounded, safe to touch. We're also running the go-kart. This is very much, an intro to the Formula Student project. It runs at lower voltage. It's a lot safer. And because of that, it's a lot more of a platform to get hands-on and learn about the structures of electric cars, what different components are. This thing in itself relates perfectly. It's a perfect education tool that refers to the Formula Student vehicle. So because of that, most of you who will sign up will start on the go-kart, learn the basics, learn what the electric car is about, the different blocks that are involved with building electric cars, and then move on from there to the Formula Student vehicle. Big plus we have with the go-kart though is because it's kind of a test bed environment, we can test loads of new technologies on this car. So we have plans to implement AI on the car, for example, but maybe we want to try implementing new kinds of steering, new forms of power transfer, and so on and so forth. As for what we're building baseline on the go-kart, again, the go-kart needs a battery monitoring system for the same reasons as the Formula Student car. It needs body work done. So if you're maybe a designer or you're an art student or you're an aero student, this would be a perfect little part of the project to get your hands on. We need motor controller tuning. This is the same as the Formula Student vehicle, how we can maximize power. So if you're into power management, power systems, all of that kind of stuff of the EE side, that'd be a great project to get into. And then if you're more of a computer scientist, we can look at implementing some AI systems, having a look at some of the new algorithms that come out recently to help with that. And maybe if we get around to it, some implementation on Raspberry Pis, let's say. Experience levels. So what do you guys need to join this project? Well, not really anything. We've got the whole framework of you get tested, you have a learning environment on the go-kart, so where you can learn everything you need to know. So realistically, we can facilitate for all levels and all interests, as you've seen. Really, all we need from you is enthusiasm. This comes to the other side of it. What do you get out of this project? Hands-on experience in a massively developing industry. I'm sure I don't need to tell you with all the Tesla stuff that's going on of how influential electric cars are becoming. This will give you a really good understanding of how the makeup of electric cars and how they're built and what you've got to think about, etc. Bolster your CV. So not only is this done through BRES, it's also done through Formula Student, another society that's run on campus. Both of these societies are great things, extra curricular activities that you can bolster on your CV and say, look, this is what I did in uni. These are the interests I have. This is why you should employ me, etc. And race days, we'll be going, hopefully, COVID forbid it, to race around the racetrack, Silverstone, etc., where we can actually test out what we built. What's our timeline? This is very general. Just in November, we'll do intro projects. We're planning to build a little introductory project, electrical kind of thing, so you can get used to all the equipment we'll be using, so power packs, function generators, oscilloscopes, etc., etc. In December, we'll find out what you're interested in, what you're keen to do, what you want to get your hands on, and then we'll allocate those tasks accordingly. And then we'll follow a pretty standard design simulation, build and test model. And then in May, you'll be revising for your exams. We won't take you away from that. Definitely leave you to that. That's my presentation. If you are interested in the electric vehicles project, don't forget to sign up.
Hi guys, welcome to the medical robot project. I am Ryan.
And I'm Minhal.
I'm a final year computer science student.
And I'm a final year computer system engineering student.
And this year we are both leading the medical robot project.
So the aim of our robot is to assist nurses in carrying out hourly observations on patients and then create patient records in an app, and then the nurses can access the app to then access the patient records and then see checkups on patients, and it will help them keep track of the health of the patients?
So this is all in aim to try to automate the hourly checkups that they have to do for vitals. So it's vitals monitoring, and these include body temperature, heart rate, blood pressure, respiratory rate, oxygen saturation, and sometimes also in some cases blood glucose.
So we're gonna split this project into categories. So we're gonna have autonomous, mechanical, design, sensor array, and the application side. Basically help us structure the project even more.
So there's going to be an autonomous side, which is going to be all about the movement of the robot, whether that is maneuvering throughout the hospital or actual movement in and around the patient. Around the patient, not in the patient. Then you've got sensor placement. So obviously some parts of the robot with the sensors will have to move to collect the data, so that will also have to be automated. And then the motions to interact with the patients is more on that.
And we have the mechanical / electrical side, which is basically focused around the robot build. So what the robot is going to be built of, and then the connection, how we're going to connect the sensors, and what kind of power management system is going to go into it, so like batteries and the other power stuff.
We've then got the design, so obviously we need to design the robot. We're going to be needing to design the best way of using all the sensors that we're going to be using together, because obviously some sensors can be used at the same time in the same place, some cannot. So it's going to be a matter of figuring out what the best way of designing all these things are, also the best way of designing the motion system of the robot itself, etc., etc.
And we have the sensor array, so we have a bunch of different sensors that are going to go into this robot. So we have to basically figure out what is the range of sensors involved and how they're going to communicate with each other, and then where they're going to be placed on the robot for them to be interacting with the patients.
And then we've got the application and web server side, which will be focusing on what happens with the information once the robot collects it. So the database that all the information goes into, the application that accesses that database to provide records of the patient's data, that can provide alerts to nurses and doctors when some information is not what you'd want it to be. So that's another side of the project.
And then we're going to be working in teams in this project. So we're going to have one big team at the start where everyone from different backgrounds, different experience level are going to be working together. So we're not experts ourselves. So anyone who doesn't even have any knowledge about this is welcome to join. As long as they have passion or genuine interest in this, they are more than welcome to join. You don't need to be an expert to join, or there's no certain criteria of experience level you need to have. And then we're going to have different activities, which is going to be based around our problem solving tasks, which will basically tackle the problems that we're trying to push forward with this robot. So such as we're going to give them tasks like measure blood pressure through non-invasive ways. And then we're going to allow everyone the opportunity to work on all aspects of the project. But then if anyone is interested in any part of a single project, then they can find out through taster sessions if they like a certain part in a project, and then they can tell us we want to work on this, and then we'll allocate them into groups and then put them into what they're more interested in.
So then obviously this year we've got our project timeline. Obviously it's 2020, so things aren't quite going as you'd expect. We're very much going to try and stay as digital as we can this term, and then focus on the actual physical aspects more into the second term. So for this term, after this launch event, we'll go into boot camp, which will last through to the beginning of November. Once we get through boot camp, we'll be diving straight into the project with the design aspect, so designing of the robot itself, designing of the app, designing of the sensor array and how all of that will interact with each other. We'll also be starting training on autonomous, so for those who haven't worked with autonomous before, for those who have, we'll be starting on getting people who haven't worked with it before familiarized with the concept of actually developing autonomous, and then also starting to try and build some of the autonomous aspects so that when the robot itself is built, or getting to a stage where it can be tested, we have autonomous ready for that. And then that would be going into December, where as of December, we'd like to start diving straight into actual testing and prototyping, whether that's simulation or whether that is actually physical construction, and seeing whether things work or not, so that when we come back after Christmas break, then we have a really good idea of what we want to use our physical lab time to actually build for the final project. Well, thank you very much for listening. There will be a Q&A session after this, which I will not, unfortunately, be there for. But Minal will take it away and answer all your hopefully excited questions.
Don't worry, I got you all.
Okay, and so we're back to me because I love the sound of my own voice. I will be leading the 5th project, so that's the fundamentals, and it is what it sounds like. Essentially, it is covering the basics of what we do and the basic skills that you might need. It can be considered essentially an extension of bootcamp, so we've learned those core skills, and now we're applying them to a project to see why we need them and how they work together, and hopefully it'll be as practical as possible. So this year we will be doing a maze solving robot. So here's a little video of a maze solver. This is one that we built with some Chinese university students 2 summers ago, I believe. Basically all it does is solve the maze and try and knock into the walls as little as possible. So what we're going to do is we're going to do a 5-week crash course, essentially. We're going to do some overview of the logic and components involved, why we need them, and then we're going to do some 3D design, so looking at that 3D modeling aspect and then printing it and what we need to also consider for that. And then we'll make some circuits, we'll do some programming, and we'll look at the logic for a maze solver as well. At the end of all of this, there will be a competition, so it will just basically be, here you can see a maze on the right. It will be the fastest around the maze wins, with time penalties for every collision or knock on a wall. Prizes yet to be confirmed, but honestly this is a great entry-level project, so if you don't feel like you understand fully all the things to do with the rest of the projects you've just heard, you want something a little bit slower and kind of more grounded, then this is kind of for you. Alright, so now we're going to switch over to some other guys who are going to show you some of the upcoming events we've got, some of the exciting things that you can get involved with, as well as the projects.
So yeah, as Ben said, our first social event of the year is a pub quiz. Thought we'd start off something simple, basic, and online, obviously due to current climates and whatnot. So get into it. When, where, and what for. So as I said, it's a pub quiz. It's Thursday, 15th at 6:30 p.m. It'll be on Teams. And don't worry, I will drop the link in the general team channel, and if the WhatsApp groups for your various teams and whatnot have been created or are yet to, I will happily drop them too. It is totally informal. Feel free to pop jokes at me. I'm not sure about any of the other committee members, but feel free to at me. Just remember I am the treasurer and I have the money, so you don't want to upset me. But we thought we'd start it off very simple because it's a get to know us. It's a way for us to have a conversation with you, have a few jokes in between, answer some funny yet probably stupid questions that make no sense. And yeah, get to see some faces, especially with me because I'm away at placement right now, so you may not see much of me, so it's a great way for me to put names to faces, see who's working where, who's doing what. A lot of fun. But most importantly, it is bring your own booze. Other beverages are acceptable, of course. No one's going to stop you. I can't tell you what you can and can't drink or eat. Do not worry, you're more than happy to do whatever you want. In terms of other online events, I'm hoping that maybe you guys can help us out a bit. I've got a few other ideas from some online things, including I've come across some new virtual escape rooms, and maybe I was thinking we could run it down to groups of the actual teams itself and see who can complete it the quickest and whatnot. So it's sort of like a regular escape room, but yeah, online and whatnot. It's quite fun. We'll try that. Any other suggestions are welcome. And do not fear. It's going to be multiple choice. I'm not going to ask you long-winded questions that ask you to type out 1,001 words. That's what university's for. We're not here to do that. A, B, C, D. And if you all get it right, it's based on the quickest and whatnot. Hopefully you enjoy it. Love to see you there. And we will miss Ben's voice, so I'm going to send it back then.
Hi everyone, my name's Rob. I'm an MSc AEEE student and a former BRES member.
Hello, and I'm Bransell, a BN EEE student who's just graduated and also ex-BRES committee member.
Today we'll be introducing you to the virtual sumo competition. As the name suggests, sumo competitions involve two guys smacking each other and pushing each other out of a ring. Of course, we're the Robotics Society, so we'll have a pair of robots trying to blow each other into oblivion. So as you can see here, of course, unfortunately, due to current circumstances, we can't do it physically. So we are doing it virtually, and as you can see from the two angry-looking blocks of cheese, one has to push the other one out of the ring before the other one pushes it. Of course, if they do both somehow fall off, it's a stalemate and a draw.
So the platform that we're using this is our sponsors platform, Roboton.io. So this is an online platform for robotics competition. It has a lot of different modes in it. There is a line racer mode, a pendulum control loop, and a maze follower. But the one that we'll be using is the sumo robotics one. So this is really great. You can program it in 3 different programming languages, JavaScript, Python, or Blocks, which is very similar to Scratch or Lego Mindstorms if you've used that before. And even better, it has tutorials built in. So even if you have no experience using any of these languages, Roboton.io will get you up to speed very, very quickly on that. So this is the web page that you'll see when you sign in on it. On the bottom right there, you've got the tutorial, which will walk you through both how to use the platform and how to program a robot in the language that you've selected. On the left, you've got the simulation panel, which will allow you to simulate and test your robot against other designs. And on the top right, you can actually see that you've got an opponent code tab as well. So if you want, you can assess it against a friend's robot or trial your programming against a different algorithm or strategy.
So the format of the competition, we're going to be live streaming it on the 28th of October. Entrants have until quite literally the last second of the 27th of October to submit their designs. We will be giving out prizes. First place will get a Raspberry Pi Zero W kit. Second place will get a Teensy 3.2, which is essentially just an Arduino on steroids. And third place will receive an STM Nucleo, which is again an Arduino Nano but turned up to 11. The competition will be run as a double elimination knockout tournament. And that's about it.
Yeah, so there you go. So if you follow the QR code or the link to the sign-up form, we're just collecting names and student emails. So we'll be sending around the full rules and details of the competition over the next week or two. And we're really looking forward to seeing what you get up to. It's great having a programming challenge as well, because anyone can participate in that. So
yeah, we hope to see you there.
Okay, so on top of the pub quiz tomorrow and the sumo bot competition that's ending in 2 weeks, we also have the Brunel Robotics and AI Expo. This is the first that we're putting on. We're hosting companies from all around the UK on the 26th of November 2020 between 10 and 6 p.m. You don't have to be there for the whole day. It's an online virtual event. But we will have companies speaking in slots so you can listen to who you want to. But the companies here, I can show you, will be doing industry talks. There'll be some various technical demos and some Q&A sessions as well, so that you can join and ask questions and find out about what these great companies are doing and who's leading them. Okay, so that's obviously been quite a lot of information. To break it down, there are the projects. So there you can see on the left-hand side, figure out what you want to do. And then we've also got the events. So we've got the pub quiz tomorrow, got boot camp, which will be starting with the Fusion 360 introduction on Tuesday. Then you've got the Sumo Bot deadline on the 17th at midnight. Make sure you enter before then. And then the Brunel Robotics and AI Expo that I've just explained on the 26th of November. We will obviously be putting more information about this on like social media channels and sharing it, but get these in your diary. So what do you need to do now? What's the next step? So firstly, make sure to follow us on social media. That's at Brunel Robotics on both Instagram and Facebook. I realised I'm covering up the camera. There you go. That's on both Instagram and Facebook. We have a Facebook page and a closed group. The page is more kind of like the front end. Closed group, join that, and it's just for Brunel students, and it's just where we kind of share meeting updates and stuff as well. So follow us on social media. Grab your standard membership. So log into the studentunion.com website and grab the standard membership, not the other one, just the standard one. And then thirdly, joining the BRES team using the link available in the description of the video below. So the Teams link is going to be where pretty much everything happens, but there's also the WhatsApps. There's a WhatsApp link as well, so in case that doesn't work for you, use the WhatsApp link. So make sure you join the team. Once you've gone into that link, you can find all of the projects and you can just join which one you want. And then the Q&As are going to be in Microsoft Teams. Okay, so the Q&As won't be on WhatsApp, so make sure you get the Teams one. Follow the link. If it doesn't work, then you can also use the Q&A links that we put down in the video. But note that if you just join the Q&A links, that won't actually join you as a member of the team, if that makes sense. Any questions, obviously feel free to email us at brunelrobotics@outlook.com or message us on the WhatsApp link. Let us know. There's a list of all the projects, project chats that we'll have on Teams and WhatsApp. But great, thank you guys. What we'll do is we'll leave this slide up. And hopefully we'll see you on the Q&As now, where all the rest of the speakers should be, the team leaders should be waiting. Cool. Thank you very much, guys.